calculator is useless after the point if you delete the list, but I have to come around and fix it. So we did stat, we did edit, and everyone is here. We agree? So what if you have stuff in, you're going to follow along and do what I did. If you don't have stuff in, which you probably don't because you reset your calculator, that's good. But when we do get data, this is what you are going to do. Everyone paying attention? I don't want to delete the list. It will be gone. We can pretend it's gone for forever so that no one makes me have to come over here and change 4 of yours. Okay? I want to clear the lists. So what I do when I have all this stuff in here is I'm going to go up there, arrow up, and I'm going to go clear and then enter. And it clears the list because I don't want to delete it. And if I go up here, I go clear and then enter. And it clears my list. So everyone should have clear lists in front of their faces, right? Now we're going to type our data into our calculator, the independent in X and the dependent in Y. So I'm going to go like this. I'm going to go 1996. I'm not going to arrow down. I'm going to hit enter. Okay? So you fill in all those into your list. So you're going to go stat, edit, now fill them all in. 1996, 1998. And if you pay attention this whole time, this is a really not stressful lesson. If you don't, it's a very stressful lesson. There is no in between. And then you just arrow over and hit enter, and then arrow over and start your next. Okay, so step 1 is to get the data into list 1 and list 2. We agree? Now at least the data is in our calculator. The next step is going to be getting our calculator to actually come up with the equation. Before we do that though, we're going to do B on the paper. B says turn on the R squared value. Okay? I'm going to explain what that means. You don't have to redo B every single time. Once B is done, B is done. The only time you'll lose the R squared value is if you reset your calculator, then that goes away and you have to redo it. But B is not something you have to do every single time. A and C and D and E you do, but B is like a one-time thing. So, I don't know if you know this, but your calculator has a catalog button. The catalog button has every single type of thing that you could do on your calculator in it in alphabetical order. So if I wanted to find like greatest common factor, I could go second, and then catalog and just get till I get to GCF and type that and use that. Unless you know how to use it properly, it's not going to get you anything anyways. But that's where all your stuff is, right? I want to turn the diagnostic on, the R squared on, which doesn't make any sense to you right now, but it will. So how I do that is I go second, catalog. Because when I press second, I'm always using the blue words above. And now it's in alphabetical order, so I'm going to go to diagnostic on. So you're going to press the button for a little while.
Where's catalog?
Second, 0. And on your paper it says it under B on your paper. So you go enter, and then you have to hit enter again till it says done. So we are on the back side of the sheet. On the back side of the sheet it's giving us steps. No. So you go to diagnostic on, and you press done. Then when it's done, you have an R squared value. Now I just want to explain to you, everyone put down their calculators once they have that. Set your calculator down when you're paying attention. Diagnostic on, and then they'll say done. Now, let's press enter, and then it'll say done. Yes. Okay. Remember you're being recorded too. Okay. Always a little reminder. So what I need you to do is to pay attention up here. So calculators are done. So and down. So when we do the diagnostic on, it turns on the R squared value. What the heck is the R squared value? You're just paying attention. You're not writing this down. I'm just explaining it to you. So if I had this data, the data in the table is actually XY coordinates. That's all it is, XY coordinates the whole way along, right? So the top one is the X, and the bottom one's the Y, and I could sketch that coordinate. Top one's X, bottom one's Y, I could sketch that coordinate. These are just coordinates. So if I have coordinates like this, and I plotted all the coordinates, my calculator is going to get a line of best fit, which is called a regression. That's what it's going to do. And it's going to tell me what that line is. Now, if my line passed through here, and this was my line, my R squared value, if it is 1, that means that every single coordinate actually lands on the line that it gave me. So if it gives me a regression equation and the R squared is 1, that means 100% of the data lands on there. Okay? This one might have an R squared of 0.98 or something like that, saying 98% of the data falls on that line, right? Now, the lower the R squared value, the crappier it is. So if I had something like this, and it's going to give me a line of best fit for all those points. If I pick a linear regression, it's going to give me a line of best fit like that. The R squared value might be like 0.50, like 50% of it would land on it. That's not a good R squared value. The higher the R squared value, the better the line represents the data. Okay? So why do we care about R squareds? Well, we only care about R squareds if and it's only for like one specific question is all we care about the R squareds. Because most of the time, if they give us data, they have to tell us what regression to use. So the only time that the R squared actually comes into account is if we have A, B, C, D, it's a multiple choice. And here I have like linear regression, and then quadratic, cubic, and we'll say sinusoidal. You don't even know what that is. Anyways, they'll give you some data, right? And you plug it into your calculator, and they'll say, which of these best fits the data? Well, you'll type them into your calculator, and then you'll look for which one has the best R squared value. So you'll find the linear line, and say it has an R squared of 0.96. And then we get the quadratic regression, which I'm going to teach you how to do right away here. And it gets me 0.98. And then cubic is 0.7, and sinusoidal is 0.48. Which one would I pick? B. That's it. That's all the R squared is really there for. If they don't give you the regression, you have to tell them which one best fits. You just look for the highest R squared value. It's called the correlation coefficient. Just tell you how much correlated the data is to the actual line that they gave you. Okay, so in your calculator you have data, right? So if I stat and edit, you don't have to do this. I'm just showing you, you have data in your calculator. You all typed it in, correct? Then we did B on this paper. We're on the paper. We're on the back side of the paper. You're on the paper. B does not have to be done all the time. Once B is on, unless you reset your calculator, your R squared value is there. Okay? We're going to C. So we put data on, and now we have to determine a regression. Now I'm going to tell you that this one here is a linear regression. So it's either going to tell you to determine a linear regression, or it's going to tell you to determine a regression in the form y equals ax plus b. Either way, that's linear. You need to know that if they say y equals ax plus b, they're asking you for linear. For this test, we're only going to have the options of 4, 5, or 6. Those are going to be the options we can pick from our calculator. So what are you going to do? You want to get a regression. So we put the data in. That's the first step. The second step is to follow C. Or it's not C, sorry. Identify the polynomial. We identified it. It's linear. Then we do D. We want to get the regression. So you're going to go stat. It says it on D. You're going to go stat. And then we're going to calculate something. We want to calculate a regression. Which one of these do we want? Remember, our options are 4, 5, or 6. Those are the only options we have. So we want a linear regression. Which one are we doing? 4, 5, or 6? Don't say 8. That is not an option. 4. We're doing 4 because 4 is linear, correct? So we go stat, we go calc, over to calc, and we pick number 4. Now if you have this screen in front of you, put your calculator down, grab out your phone, and ignore me. If you do not have this one on, if you just have the word lin regression on, you're following me right now. So most of those are TI-83 calculators and the odd TI-84. So if you have this screen, you can put your head down and completely ignore me. And I would very much tell you to completely ignore me. So if you have this screen, look down, don't even look at this board, you're not following along. Okay. If you don't have this and you have just lin reg on your screen, right? You probably should have lin reg. Okay? You guys are following me now. So there's a few of you. Who are the people who has just Lynn Reg on their screen? That's you two. Okay. You do too? Or you have this? Okay. Then you're following along. Yeah? Let me see. You had Lynn Reg. I don't know what you did. Go stat, count. Just go stat, count. You press more enters. Stat, count. You have what I'm talking about right now. Okay, so you're following along with me. So if you have the Lin, Reg, and the AX plus B on your screen right now, you're following along. So you're on D on the very bottom. It says the main screen should appear with the chosen regression type. Press enter. So you're going to press enter now if you're the people who are following with me. Okay, and now you have an equation written in front of your face. We agree? Do you guys have that? Okay, so you don't have this, but you have this now sitting in front of your face after you pressed enter. Right, Hugo?
Yeah.
Okay, so you have that sitting in front. Now you need to get that to move into your y equals. So if you're someone who's following me right now, you have the older calculators, look at the very bottom of your page. There's an older, for under E, there's an older calculator section and the newer one. You're going to cross out the newer one because you are the older calculator. Totally fine, still gets you an answer. So you're crossing out the newer calculator portion if you're following along with me right now. You're going to follow the older one. So it says here, you want to send the regression equation to y1 by pressing y equals. So after you do this, you're going to press y equals. Okay? Then you're going to press vars. It says down here, press vars. Then it says number 5 statistics. Then you're going to go over to equation. And you're going to have an equation in your y equals. Does everyone have that with the older calculators? So vars, down to statistics, over to equation, and hit enter. Or do you have the older calculator? That one does sometimes, but it's not the faster way to do the calculator.
No.
Are you supposed to see something? Is that what
No, just press your y equals and see if you have an equation.
I did.
So you probably have the older calculator. You need a new calculator. Yeah, you have the equation. Yeah.
Yeah, wait, I don't.
You have the equation. No, mine's just arrowed over. You have the equation. We have the exact same one. Mine's just at the very end and yours is at the first time. Same equation. Okay, so if you have the older calculator, everyone paying attention? Anyone with the older calculators? Go to your y equals again. You're still in the older calculators. Same people I just talked to. Clear out your y equals. We're going through the steps again. So clear your y equals. Use the older calculators. Okay. You're going to clear this. You're going to go stat. You're going to go calc. You're going to pick number 4 again. You're going to hit enter once because you don't have the same screen as me. You hit enter once and you have this now on your screen. We agree? Then what is your next step? To go to y equals. Then you press vars. Down to statistics, number 5. Over to equation. Enter. And you have it in your y equals. Okay? So if you have the older calculators and you have it in now, put your calculators down, start ignoring me. Other people start paying attention. If you look on E, at the bottom of your sheet, there is a newer calculator step. It's at the bottom. It's shorter than the older calculator step. You see it? You are going to cross out older calculator steps. So if you're someone who right now, you go stat calc number 4, you have this sitting on your screen, you have the newer calculators. You will cross off the older calculator steps in E. You do not need them. You have newer calculator steps. So, your calculator right now is going to calculate the regression, but it also needs to learn how to put it into the y equals. Okay? So you're going to do this. When you get to this screen, you're going to go, if you look, it shows you here now on E in the newer calculator, it says after picking the regression, which you did, you picked number 4, you want to scroll down to store regression equations. You want to scroll down to here. And then you're going to press vars. But you're not going to follow the same steps as everyone else. You're going to do vars. You're going to go over to y vars, and you're going to hit enter, and look, where is it storing the regression equation into now? y1, which is where I want it to go. You hit enter again, and hit enter again. And now you'll actually see your equation where the other one seen it earlier, and press y equals, and yours is sitting in there. It should be sitting in the y equals. Your dad is different than you messed up something with your dad. Like go back into your lists are different. Yeah. If your numbers are different, you either didn't pick 4. Did you pick 4? Then if you picked 4 and your numbers are different, it's because your list you typed something wrong. Today, all we are practicing, this is what we're practicing. Everyone's paying attention? Everyone has to be paying attention now. What we're practicing is, step 1 is to get the stuff in lists, right? Because if we don't have the stuff in lists, the calculator can't find an equation. The second step is to get an equation and get it into your y equals, okay? If I press graph right now, I'm seeing no graph. If you press graph, you're seeing no graph. Because your third step has to be to change your window. So your first step is get stuff into lists. The second step is to get an equation. And the third step is to change your window to fit your data. This is the best window changing you will ever have in your life because you have data in front of your face that you can look at. So if I go and look at my data from today, what is my lowest x? Right now your lowest x is probably 10 and your highest x is probably negative 10 and 10. My lowest is 1,996, which we read as 1996. But still, it's 1,996. This is why we're not seeing any graph, because you're maxing out at 10, and this baby's starting at 1996. Okay? So what you do is you're going to look at your data, and you're going to make always your x minimum lower than whatever the minimum is here, your x max higher than whatever the x max is here, your y min lower, your y max higher. So what is my lowest x currently? My x minimum? 1996. So I'm going to make mine be 1980. So I'm going to go to my window, and I'm going to make my x minimum be 1980. Then I go here, and I say, what's my highest year? 2009. So maybe I make it be 2020, right? I just need to make it more. That would be my x max, because that's my x list. We can leave scale for now. Okay, what is the lowest distance that these guys rode their bike in an hour? 78. What's the lowest you could ride your bike? 0. You just sit there and never ride it. And then an hour would pass and you're still sitting there. You're the worst person for this record ever. Like, I'm just sitting here. But at the lowest it could go is 0. So if you want to go 0, you can. If you want to do 65, it's lower, that's fine. It doesn't matter. You just need to go lower. So I'm going to make mine be 0 because that's the lowest I could go. But you put 65, it's fine, as long as it's lower than the lowest and higher than the highest. So what's the furthest they have rode bikes so far? 90.6 kilometers. Now, I put 2020, but remember for the year. But if they ask me for 2030, my calculator can't find it because my X max was 2020. So always make sure if your calculator's fighting you finding something, which we're going to do tomorrow, it's probably because your window's too small. Like if you're looking for 2030 and you X max out at 2020, it can't find it. Okay? So always keep that in mind. Does my window fit what I need it to fit? So this one is 90.6. I'm going to put 100 as my Y max. And I'm going to leave my Y scale for now as 1. It doesn't really matter. And I'm going to press graph. And now I can actually see it because my data fits what I just put. We agree? Okay. Our job today is to figure out how to get stuff into our calculators. Now, there's questions about this, right? I'm not even writing the equation down. I'm not answering any of the questions they're asking me. I used to make you do a regression then answer the questions, which is the other side of that sheet. Then I overwhelmed everyone. I just need you to be able to get it into your calculator and see it for today, okay? Rather than all the steps from everything, and then you're just completely confused, because I used to do that like 5 years ago, and it was the worst thing ever. So we're not doing that. We're just getting it into our calculators. Does everyone have it on their screen? And it looks like that? Okay. I'll help you in a second. So, yours doesn't look like that? Check your window. Is your window this? 1980, 2020, 0. Remember, if you put 60 or something here, it's going to be different. Is it the same? Yeah, that's the problem. Yeah. Don't do negative, do 1980. Is your window the exact same as mine? You put your equation in twice. Your equation is different. You must have done it twice and it just doubled it into it. Okay, go to your y equals now. The very first thing you do before you go to, you just calculated it twice and just set it on twice. Okay, we're going to example 2. The very first thing you're going to do is you're going to go to your y equals and clear it out. Every single new question, you're going to go to your y equals and clear it out as your very first step. Why is that the case? Why do you think I'm pushing that? So it doesn't go in twice, or so you don't think you didn't find the actual equation, but there's an equation in there and a graph in there, so you're like, sweet, I can go. It's like, no, it's off the last question. You're answering now the new question's answer is off the last question's equation. Do you see how that can happen by oopsie? So your first step every single time you start a new equation is to go to y equals, clear it out, so you can't have that issue. Okay? So we're starting again. This one here is example 2. Example 2 is Matt buys t-shirts from a company that prints art on t-shirts and then resells them. When buying the t-shirts, the price Matt must pay is related to the size of the order. The larger the order, the less he pays. That's how it always works in the world. The more quantity you buy, the cheaper you can get it for, right? So this is your data. This is your X, the number of shirts. The cost is Y because the cost is dependent on how many shirts you buy. And it says Matt has misplaced the information from his supplier about price discounts on bulk orders. He would like to know how much he's going to have to buy to get it below 150. That's actually a question we're going to get to tomorrow. I don't care about that question. I just want you to get a linear regression. So everyone's starting again. So how do we start? We start at A. A says stat, edit. So I have to clear up my y equals, and then I go stat, edit, and then I go up to L2 and I go clear, enter. Then I go over and up to L1 and I go clear, enter. And I'm typing in my lists. So I'm going 500, enter. 700, 200. And then 1.95, 5.2, and then 3.51, and 1.69. With mine, I have to hit enter so that it shows up. So I have my list 1, and I have my list 2. We agree? Okay. I want to calculate our linear regression. So I bypass B, because B gets me my R squared. C tells me to figure out what regression we're doing. I said linear, that's great. 4 is going to be calculating it. So how do we calculate it? We're going to be on D. How do you calculate it? It says go stat, over to calc. And which one are we picking? 4, 5, or 6? 4. And now at this point, you either hit enter and use the old calculators and you follow the other steps, or you go down to store regression equation and use new calculators. So everyone's doing their steps right now. Try and get into your y equals. See if you can get there. You're following your steps. The newer calculator steps the bottom, use the newer calculator. The older calculator steps the bottom, use the older one. Step 1, putting data in. Step 2, getting equation to y equals. Step 3, change windows. So we go to window, and it doesn't matter if it showed up because your window before worked. You need to change your window to the data you have in front of your face. So what is the lowest number of t-shirts here? Don't tell me it's 500. That is not true. It is 200. What is the lowest number of t-shirts you could sell anyways? 0. So I'm just going to make it be 0. Okay. What's the highest number of t-shirts that are sold? 740. So I'm going to make it be 1,000. And then leave my X scale be what it is. Doesn't matter. What's my Y minimum? Cost per shirt. What's the lowest I have here? 169. I'm going to make it be 0 because it's the lowest you can pay for a shirt is nothing. Which I don't know who's selling those, but I want them. Okay, and then the Y maximum, what's the highest they sold the shirt for? $5.20 when they bought the lowest amount. So I'm going to say 8. It doesn't need to be way higher than that because when you're selling 200, it's 5 point, right? And then press graph. You should have some sort of line. Okay, we're moving on. Let's look here. We're going to example 3. Example 3 talks about the world record time for the men's 100-meter sprint was 10 seconds in 1960. So the year 1960 is represented by 0. And this one says linear regression. So we're doing linear regression again. We're not answering any of the questions. That's for tomorrow. I just want you to get a linear regression. So step 1 is to get it into the stat. Actually, step 1 is to do what? Clear your y equals. Then get it into your list. Get the linear regression. Change your window. Try it out. Every single one of you. I'm not giving you steps anymore. Try it out. If you're stuck, you can call me over. But I'm not stepping you through. Stop. Your list might be, check your list, because sometimes if you missed a data point or you press enter at the end of the list, one list is shorter than the other, so it won't be happy with you. Okay, so everyone should, if you ever have an error, paying attention, sometimes one list is longer than the other, and that happens most often when people don't press enter at the end of their list, so it doesn't acknowledge that last input. So you have to press enter in order for the list to take it in. So sometimes, if your lists are lopsided, they'll say dim mismatch, gets mad at you. Okay? So we go stat, calc, linear. For you guys, it might be different buttons. For me, it is this. I have both calculators, so I know them all. This says that the R-squared value, this covers about 81% of the data. So it's good, but it's not like super awesome, right? Not every piece fits it. And then we go to our window and we change it to suit it. So this one, I need you guys to look at this. Some people will say, well, I have to start at 0 because it starts at 0. Let's look at the title of X. The title of X, which you should be paying attention to, says years after 1960. Can I have negative numbers? Yeah, what if I ask you for a 1950? What would you have to put in for X? Negative 10. If 1960 is 0, 1950 would be negative 10, wouldn't it? 1940 would be negative 20. So we can have negatives in our X on this one, just because of the way the question is asked. So I'm going to go to my window and I'm going to put negative 10 here. Then it says 49 would be 49 years after 1960. I'm going to go to 100. I'm just going to double it. So I'm going to go to 100. And then here it says they start off at 10 seconds. They go down to 9.58. So that's a really small window of Y values. So I'm going to make my Y minimum be like 7 and my Y max be 12 or something small. And then press graph and I should be able to see a linear line. Now this one makes sense to have negative X values because it says years after 1960 is 0, right? If I ask anything younger than 1960, I'm dealing with negative X values, which is totally fine. So you have to watch the data. Now I have one last one to go over with you, and it's a quadratic and I need everyone's attention. It's a big kahuna one. It's not this one, it's the next one. It's 2 ahead. So it's going to be on this one, example 6. Example 6 has a lot of data. Can I get you guys to all pay attention? Because if you call me over on the test and say this doesn't work, I have everything in 6 lists, I will be sad. Now most often they don't give you this many lists. I'm going to cut out the third one just to prove, but I want to prove a point with this. And everyone look here, please. If you look at the lists here, Do you see them at the top? This one says speed in kilometers per hour. This one's distance. This question is, Audrey is interested in how speed plays a role in car accidents. She knows that there's a relationship between the speed of the car and the distance needed to stop. The faster you're going, the longer you need to stop. Obviously makes sense, right? She has found the following experimental data on a reputable website, and she would like to write a summary for the grad class website. Now it says after this that she wants the quadratic regression. It's on the second page. It wants it as a quadratic. So instead of picking 4, we're going to pick 5. But I picked this specifically so you could see the data and why it is like this. This is not list 1, 2, 3, and 4. That is not how this goes. You will always have a list 1 and a list 2. You will have never more than that. So figure out how you're going to put the data in. If you want to put 3 and 4, you don't. It doesn't ever happen. There's a 1 and there's a 2. The rest should always be blank. Okay? So look here. This is speed in kilometers per hour, and so is this. This is distance in meters, and so is this. All she did is normally what she could have done is she could have went speed and then took these speed numbers and kept them going. I would just need a way longer piece of paper, correct? And then take the distance and keep them going. So all this is this is xy, 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 and then this is just take this. You could literally take this and put it at the bottom, and take this and put it below that. Because this is still xy, 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 xy. Does that make sense? So all of the speed is list 1. Just make sure you put the proper y with the x, right? And then these are all list 2. So go type that in. Get a quadratic regression. So instead of 4, I'm now going to pick 5. Our only options for this unit test are going to be 4, 5, or 6. I'm picking 5 for this. So everyone's going to try it out. And when you're done, you're going to compare it to mine, and we're going to see if we have the same thing. Everyone's trying it. Type, type, type. Lots of typing.